Well, hello everybody. We are team number one, and we are hoping that you are having a good day. We are gonna be talking about leaching, so let's get started.
And the fundamentals. One group of operation for the separation of components of mixture is based on the transfer of matter from one homogeneous phase to another. These methods use difference in vapor pressure, solubility, or diffusivity. Also, these methods grew up under the heading of mass transfers operation, including leaching and solid liquid leaching. It consists of the treatment of a finely ground solid with a liquid that dissolves and extracts a solid contained in the solid. Leaching is one of the oldest operations in the chemical industry. Although, it originally referred to the percolation of liquid through a brittle solid. It's now used to refer to operations by other means of contact. The solid-liquid extraction is a basic operation whose purpose is the separation of one or more components contained in a solid phase through the use of a liquid phase or solvent. The component or components that are transferred from the solid to the liquid phase is called solute, while the insoluble solid is called inert. The solid-liquid extraction is called by different names, depending on the purpose of the process. It's also known as leaching, washing, or percolation, and others. The purpose of this operation can be diverse, since many biological substances, as well as inorganic and organic compounds, are found as mixture of different components in a solid. In leaching, the amount of soluble material removed is often considerably greater than in ordinary filter washing, and the properties of the solid can change considerably during the leaching operation. Important applications are extraction of animal and vegetable oils and fats, washing of precipitates, obtained extracts from animal or vegetable matter. An important process is the leaching of sugar from sugar beet with hot water. In the production of vegetable oils, organic solvents such as hexane, acetone, and ethers are used to extract oil from peanuts, soybeans, sunflower seeds, cotton seeds, and others. In the production of soluble instant coffee, roasted and ground coffee is leached with pure water, and the soluble tea is manufactured by leaching tea leaves with water. Useful metals are often found in mixture with large amounts of undesirable constituents, and leaching allows them to be extracted in the form of soluble salts. Copper salts are dissolved or leached from ground or contain other substances by sulfuric or ammoniacal acid solutions.
The success of a leach and the technique to be used depends on any pre-treatment that may be given to the solid. The method of preparation of the solid is highly dependent on the proportion of the soluble constituent present, its distribution in the original solid material, the nature of the solid, which may consist of plant cells, as well as the original particle size. Plant and animal bodies have a cellular structure, and the soluble constituents are usually inside the cells. If the cell wall remains intact after exposure to a suitable solvent, then the leaching action involves osmosis of the solute through the cell walls. But this can be a slow process, and the leaching rate can be quite low, because the cell walls constitute an additional resistance to diffusion. However, grinding the material small enough to realize the contents of the cell is impractical and sometimes undesirable. When the solute is absorbed on the surface of solid particles of simple dissolved in a adherent solution. Grinding or milling is not necessary and the particles can be washed directly. The rate of solvent transfer from the overall solution to the surface on the solid is quite fast and the rate into the solid can be fast or slow, but in many cases, these are not the stages that limit the rate of the total leaching process. The rate of diffusion of the solute through the solid and that of the solvent to the surface of the solid are usually the resistor controlling the overall leaching process and depend on several factors. For example, if the solid consists of a porous unit structure, with the solid and solvent located in the pores of the solid in a natural substance, there are additional complexities due to the presence of cells. As for the speed of leaching, when a material dissolves from a solid into the solvent solution, the rate of mass transfer from the solid surface to the liquid is usually the controlling factor in the entire process. There is no resistance in the solid phase when the pure matter is involved. Leaching is carried out at temperatures as high as possible. Higher temperatures result in higher solubility of the solute in the solvent, and consequently higher final concentration in the leached liquid. At elevated temperatures, the viscosity of the liquids is lower and the diffusivities are higher. This increases the leaching rate. In this case of some natural products, very high temperatures may result of the leaching of excessive amounts of undesirable solutes of chemical deterioration of the solid. As in other unit operation, the equilibrium then tends to be reached during the operation and the speed at which it is reached must be considered. Studying the various factors that affect them, the mechanisms of the extraction of a solute contained in a solid particle by means of a liquid is considered to occur in 3 successive stages until equilibrium is reached. Each of the stages had its own transfer rate, with its lowest stage controlling the extraction process. In the first stage, the dissolution of the solid is considered instantaneous, so it will not influence the process. The second stage usually controls the speed of the process, as it usually proceeds slowly. To increase the overall transfer rate, various factors such as particle size, temperature, and agitation of the fluid are usually acted upon. In addition, another factor to be taken into account to increase the transfer rate is the type of solvent, making it necessary to use selective solvent with a low noise viscosity so that it can circulate easily. The transfer of matter takes place until equilibrium is reached. This is reached when the solute is completely dissolved, obtaining a solution of uniform concentration. If the solute content in the solid is sufficiently high, equilibrium is considered to have been reached when the solution in contact with the solid is saturated. This condition may be reached easily or with difficulty, depending on the structure of the solid. If the system has reached equilibrium, 2 phases will separate when left at rest: extract or upper flow. This is the separate solution, consisting of solute and solvent. It is also called micella. Refined or lower flow. It is the residue formed by the inert solids, and the solution retained within it. The equilibrium has been reached, the solution will have the same solute concentration as the extract. And if the solution is saturated, the inert solid may also contain undissolved solute. The equipment used in solid liquid extraction process are very varied, and can be classified according to the particle size on which the solute extraction is to be carried out, whether the solvent to be used is volatile or not, or whether its recovery is of interest or not. Extractors are classified according to the contact method. The types of leaching equipment are as follows. Batch percolators. This type of extractor consists mainly of an open deposit of container with a false bottom. These extractors are used in small industrial plants for extraction of sugar, oil from oleaginous seeds and dry fruits, coffee from roasted, and milling rice and tea soluble from dehydrated leaves. Fixed bed multi-stage systems are used when the solvent is volatile under solid bed is not very permeable. It is necessary to use closed tanks operating under pressure to allow the solvent to pass through the bed. The process in which this type of extractors are used are coffee, tea, oil, and sugar extraction. Continuous percolators. In this type of extractors, the bed of solid particle is mobile. most often operating in county current. Some of the different types of continuous percolators are Boltzmann extractor, Hildebrand extractor, Bonotto extractor, and Rotosil extractor. There are a wide series of extractors used on the oil extraction industry, such as the vertical immersion column extractor, the CMB percolation extractor, and the Soxhlet extractor, which is one of the most widely used on laboratory scale, since in solid liquid extraction it is customary to work by batches or semi-continuous, due to difficulty on handling the solid to be extracted.
Applications: extraction on desired components. Typically leaching in the process of washing the sheared cane. The process by means of leaching, the sugarcane juice is extracted from the bagasse by means of zigzag mechanical washes. These washes are the same as compound soaking in the grading system. Manufacture of soluble coffee and tea instant. In the preparation of the coffee beverage, the soluble compounds of the roast and ground coffee are extracted with hot water by means of dilution. One of the factors appreciated in determining the quality of coffee is the concentration of soluble solids in the drink, which contributed significantly to the flavor and other characteristics. Extraction of oils from oil seeds. In oil extraction, the ground seeds are mixed with hot water and boiled to allow the oil to float and to be collection. The ground seeds are mixed with hot water to make a paste that is kneaded by hand or machine until the oil separates into an emulsions. There is currently a growing demand for high-value food. Component extraction systems understand both the traditional techniques of percolation and immersion, like the new fluids extraction technologies superficial. Extraction of components such as pigments, essential oils, pectin, gums, carrageenan, guar gum, xanthan gum, vitamins, collagen, obtain gelatin. Extraction of the wanted components: caffeine, lactose, fat. In order to obtain all these, we must take into account factors such as the type of solvent, temperature, and particle size.
Leaching models are useful for predicting the effects of process variables and the amount of leachate. One of the most important equation for this is the Fick law. This law is used assuming that the solid is in a stationary state and the diffusion is made in one direction. In the next differential equation, we have that J is the flux of the component in its direction. D sub M is the molecular diffusivity. C is the concentration of the component, mass per volume liquid. X is the distance in its direction. The key parameter in Fick's law is the molecular diffusivity. This coefficient has been measured for a number of compounds and can be estimated for other ones. It's important to recognize the difference between the application of Fick's law to free diffusion and diffusion within a porous solid. In a porous solid, the molecules moves through pure water by molecular diffusion. However, the concentration is expressed in terms of the total volume of solid rather than the volume of pure water. One other important is the material balances. The heart of the mechanistic model of leaching is the material balance. A general material balance equation can be expressed as The amount of material entering by physical transport less amount of material leaving by physical transport plus net amount of material formed by reactions. When it's applied to a solid with rectangular geometry, in which Fick diffusion is the physical transport mechanism, the material balance becomes like the Newton's differential equation, where R denotes the net rate of production of the molecules. The next model is used to know the contaminant concentration, and a number of simple Leach models can be constructed that can be solved analytically. The simplest and the most commonly used Leach models assumes that no reactions occur. The slab is infinitive, the bath is infinitive, and the contaminant is distributed homogeneously at the start of the leaching period. This model is the basis for analyzing data from the standard dynamic leach test. With these assumptions, the material balance equation can be solved to give a profile of the concentration within the solid. In the equation, C sub 0 is the concentration of the contaminant through the slab when leaching starts. ERF is the error function, and T is the time since leaching began. This equation is not very useful in characterizing leaching from solid file wasted. It is much more useful to obtain the fraction of contaminant leachate by integrating the concentration profile across the entire slab. The graphic shows the concentration profile in solid file wasted contaminating mobile contaminant after various dimensionless leaching times.
Innovation. Leaching, extraction, recovery, and mass transfer of compounds is really tied to emerging technologies. In fact, several authors have noticed as the use of emerging technology allows a better recovery of bioactive compounds and environmental friendly processes developing. A typical extraction process has physical limitations, like isolation non-aroma active fats or organic solvents that are usually toxic, flammable, expensive, and in some cases environment pollutants. Also, they have chemical residues after the extraction processes. That's why in recent years many novel techniques have been employed for extracting compounds of interest. For example, ultrasound-assisted extraction. Numerous studies have demonstrated that low-frequency and high-intensity ultrasounds improve the mass transfer process, improving the extraction of different intracellular components from vegetable matrices by ripping the cell walls, allowing the inner substances to flow. It can be used as a bath or with a probe. Microwave is a non-contact heat source that generates heat energy via sonic conduction between solvents and dissolved ions, which ruptures the cell wall and assists in the release of polysaccharide molecules. The change in polar molecular orientation due to alternating electric field at high frequency induces molecular vibration and rotation, causing enhanced collision frequency, increased internal pressure, and the sudden rise of temperature, leading to cell rupture and diffusion of the solvent through the cell barrier. However, one of the main drawbacks of microwave extraction is inhomogeneous heating. Supercritical extraction. The supercritical extraction method has been developed in recent years. It is used to extract substances from a matrix using a solvent at supercritical conditions, where distinct liquid and gas phases do coexist. Supercritical fluids can diffuse through solid matrices, similar to gas, and subsequently dissolve materials like normal liquids. Since many supercritical extractions are conducted close to the fluid's critical point, When small changes in pressure or temperature result in large changes in the fluid's density, this unique property leads to density-dependent selectivity of the supercritical extraction. Water, ethane, propane, butane, ethanol, and especially carbon dioxide have been used for extraction. The use of CO2 is preferred due to its non-toxic, non-flammable, and non-polluting properties, and in addition to being inexpensive. The use of pressurized CO2 results in the absence of chemical residues at the extract because CO2 is a gas at room temperature. Not only this technique is faster than conventional or traditional methods, but it is also more environmental friendly. Another emerging technologies are moderate electric field pulses or leached by enzymes, although they hadn't had a major impact in leaching. The use of this kind of technology in form of intermediate treatment during semi-continuous solid phase extraction can result in an increased soluble matter transfer by cell wall breaking. And there is also the tendency of healthcare. Hence, some studies on extraction are aimed to the control of migration to the food matrix, like aluminum, plastic, or ink, for which leaching is not desired but intended to be stopped. Conclusion: leaching or extraction is an old reliable operation that have been useful since long time ago for its simplicity and efficiency. When extracting the different products, we obtain different results according to the raw material. It usually must be conditioned to promote contact with the solvent and facilitate its extraction. The tendencies are studied for processes like sugarcane or starch extraction. Math equations and models are useful because of their simplicity and capacity to describe the evolution of the extraction processes. Innovation in the area is pointing towards to the combination of different technologies that mostly are trying to enhance the efficiency by breaking the cell walls or other structures from the raw material as a pretreatment or a bypass from the same leaching. There are also some intentions to improve the conditions of the extraction, although it's very early and in lab scale operation. These are key points to which scientific work and literature will be aiming.